Ladies and gentlemen, and nice afternoon. Welcome to our partner webinar. MyPV and SMA is hosting today, and together we want to present what benefits you have when you combine our two brands. Yeah, hot water and space heating is MyPV's topic. One formal thing at the beginning, you are going to receive the slides of the presentation we have prepared for you after the webinar. So there are some slides with plenty of information, with plenty of content on the slides. And in that case, it's just easy for you to take a look on the content after the webinar, because we are not going into every detail today. I just want to give you a rough overview of the possibilities you have when you combine MyPV solutions with SMA components. All right, my name is Reinhard Hofstetter. I'm for more than 6 years now at MyPV, and together with me in the webinar room is my colleague Talal Butt, and he's responsible for international sales. So if you would like to have an offer or the price list for MyPV, Talal will be your direct contact, while I'm as a product manager, I'm available for your technical questions anytime after the webinar. When you receive the slides after the presentation, you have both of our email addresses available. All right. While I'm talking, Talal is available in the chat room for your questions anytime. So if you want to have more details on the special solution we are talking about, then do not hesitate. Just send the question via the chat on the right side of the screen to Talal. What we have here is a short overview about the MyPV history. It's a pretty young company. The whole story began in the year 2011, actually as a distributor for PV components. But quite soon our business model changed. We became a manufacturer and a developer of the solutions we are going to show to you today. What we are doing is easy to explain. You know terms like power to heat, you know maybe the term sector coupling, and basically this is what it's all about. We have developed solutions and products to create heat with solar electric power, with the surplus in your grid-tied PV systems. And one of our latest milestones in the year 2022 was our new company building. And also in this project, it was quite clear for us that we are creating this building with wires instead of pipes. So this is one of our slogans. In my past, before I started at MyPV, I worked on solar thermal systems. So all systems that use pipes and pumps and expansion vessels to create heat out of the sun. And this is an old technology from today's point of view. Now we have photovoltaics, and using wires instead of pipes, as we call it, makes the creation of thermal energy out of the sun nowadays many times easier and also cheaper than conventional solar thermal systems. And this building had such a great performance also during the winter time that we received the Energy Globe Award Austria for this project. So we are pretty proud about this building. All right, and together with me in the webinar room is Daniel, my co-moderator from SMA. Daniel, please introduce yourself and SMA for our listeners.
All right. Thank you, Reinhard, for the word and for the nice introduction. So my name is Daniel Fucik. I'm product manager with the company SMA Solar Technology. I'm product manager there in the business unit Home and Digital Solutions. Basically, our team is responsible for anything that has to do with residential energy management solutions. Be it the hardware or the platform the hardware runs on and communicates with other devices, both internal and external third party, such as MyPV devices. A few words about SMA. SMA is a little bit older than MyPV. It was founded in the 70s, I want to say, and is currently one of the largest, if not the largest, inverter manufacturer based in Europe, who also manufactures in Europe at the headquarters in Kassel. Currently with 113 gigawatts of installed inverter power and 4 gigawatt of battery inverter power. We have around 3,500 employees and over 1,700 patents registered. In the previous year, which now is 2022, we were looking at sales around 1 billion euros, and with a previous year not reaching by a skin of the teeth the 1 billion mark, staying at 984 million. But this year we're looking forward to another great year with electricity or solar electricity or PV power combining with heat and energy management. So I think this can be a great year for both MyPV and SMA, and especially the both together. So thank you, Reinhard, and back to you.
Thank you, Daniel, and also for the chance to do the co-moderation with you today. We split our two main parts. We agreed that at the beginning I'm introducing the MyPV products, but just those who are relevant for SMA combinations, and the same is what Daniel is going to do. So the future is going to be electric. We are talking about mainly hot water production in residential systems. And what we have seen many years ago is that at some point PV will become the cheapest form of energy production. So no other conventional power plant can produce a kilowatt hour of power such cheap as photovoltaics can. And when we started with this idea, with this power to heat idea for residential systems, PV power was much valuable to create heat with. So it was insane to think about using PV power for heating those days. But this has changed completely. Now it's the cheapest form of energy we have. And in that way, we can also use this energy for heating applications with direct electric heaters. Why not? We have so many advantages on the technical side by using wires instead of pipes. So sector coupling is a quite common term, especially in the German language. We are talking about sector Kopplung. And this means that you use your green power, such as power from photovoltaics, for other applications than your normal electric loads. So we see, of course, a steady increase of electric vehicles, and we also see an increase of the applications that MyPV is developing. So we are talking mainly about hot water, but also electric space heating in residential buildings. Which energy is used by MyPV? Imagine your PV power, your PV system from SMA is producing during the day. This power production changes. Also, clouds are moving on the sky, and it's not constant. Anyway, this power is used with priority for your electric appliances and your loads in the building. And if you like, SMA offers the possibility to charge a battery as well with your excessive power. The rest is normally fed into the power grid. But if you want to utilize this amount of excess power, MyPV comes into the game. We can use excessive power before it is fed into the grid. And we can do this once the battery is fully charged or when the amount of excessive power is higher than the maximum charging power of the battery, or when there is not a battery there at all. So it does not matter if there is a battery, you can always make use of your excessive power with MyPV and SMA components. So this also describes the priorities we recommend. Before we create heat with the solar power, it's wise to charge your battery first, because once it is heat in the hot water boiler or in the storage tank by our device, you cannot get back electricity out of it. So priority should be on the charging of the battery. Let's take a look on storage capacities. We need to store our energy somewhere because the production is changing all the time. And the most common way to store electric power is, of course, the battery. And no doubt, batteries are essential for the transition to renewable energies. But when I'm a little skeptic at this stage, this is just a small amount of energy we can store in a battery. Typical storage capacities are somewhere in between 5 and 10 kilowatt hours in residential buildings. On the other hand, we can heat up a 300-liter hot water tank and see there, when we heat it up for 40 degrees centigrade, for example, we have accumulated 15 kilowatt hours of energy. So now it is heat, that's clear, and we cannot get back electricity out of it. What I told you right now is that we can be a cheap alternative to batteries, but MyPV never ever competes with batteries. As I said, no doubt this is an essential technology for the transition to renewable energy. And the good news is that it works in every case with SMA control systems, because it does not matter if there is a battery or not. We can always be combined with SMA components. Before we dig a little deeper into the technology, we have to deal with the basic question: why does it make sense not to feed in the surplus into the grid? And there are different reasons for this. There are some economic reasons. Let's say the feed-in tariff has expired and you do not get much for feeding into the grid. That's an economic reason. There is also a reason of our society. We need energy independence. We need to be more autonomous, especially those days when we watch the news in the evening, we see how important it is. And there's also a technical reason. When we have PV systems on all our houses, and that's my idea of the future actually, then we run into trouble with our power grid. And to avoid the shutdown of the PV systems, we have to use every storage capacity we can get. The battery is just one solution. Power to heat is another one. And when we combine both technologies, we can increase the self-sufficiency rate to an absolute maximum. So we need all the storage capacities we have, and MyPV offers solutions to use your thermal capacities in your building, your hot water boiler, your storage tank. And beside another solution, which is a DC variant that is directly connected to modules, there are two products from MyPV which are relevant for our webinar today, because both of these devices can be controlled by SMA. There is the AC Elva 2 on the one hand, and there is a product named Actor. What is the difference? Both solutions are power controllers. The difference is that the AC Elva 2 comes with an immersion heater on the power stage. So this is an all-in-one solution. The immersion heater for the assembly in the hot water tank is on one product with the power stage, which does the linear power control of the heater. And then the Actor has the benefit that this is much more flexible, because there is no immersion heater on the power stage. Instead, there is a socket on the bottom, which means that you can connect any resistive load you want, and this resistive load is then controlled linearly by the Actor. And this linear control I'm talking about is the essential thing to make direct electric heaters PV ready. You need a very clear and accurate adjustment of the power output to make this immersion heater ready for your PV system, because the PV panel the power output is changing all the time. And at the same time, you are switching loads in your building on and off, and the amount of excessive power, the power which would be fed into the grid, is changing permanently. And our solution is adjusting accordingly. So it avoids import into the grid, and it avoids feeding into the power grid. And there are several ways to be controlled by SMA components. I have divided it into two sections. On the top here, there are the on-grid options, and at the bottom, there is the off-grid way to use our technologies together. The main part of my presentation is the on-grid application, and there are two options. Both ACLR2 and Actor, which is here on my desk, can be controlled by SMA Home Manager or SMA Energy Meter. And for the Actor and for the bigger version, Actor 9S, it's also possible to be controlled by the frequency in an off-grid systems. We are going to take a closer look on this application at the end of my section. So let's start with the on-grid possibilities we have to receive the excessive power info from SMA. We can be controlled by the Home Manager, and we can be controlled by the SMA Energy Meter. So where are the two advantages? Where is each advantage and where is each disadvantage? When you have the hardware SMA Home Manager, you have the option that the control type which is set on our device is SMA Home Manager, and you have the option for the SMA Home Manager to choose the control type direct meter communication. What is the difference? When we use the control type SMA Home Manager, we are part of the Home Manager's energy management. We are visualized in the diagrams of the Home Manager, and the whole energy management, which includes, as far as I know, forecasts and weather predictions, is done by SMA. We are just the power controller that is adjusting the power output on the resistor, on the immersion heater or the infrared panel or whatever. So the whole intelligence in that way is inside the SMA Home Manager. And this is a combination which is made 100 times out on the market. It's very well proved and developed, and it really works great. I'm going to have prepared some screenshots from the SMA Home Manager for you. And for most of the customer, this is perfect. This is a great solution, and you have combined all your appliances in the building inside the SMA Home Manager. Some parts of our customers are very special interested in the technology itself. They are very affine to technology, and they want a very fast and very accurate way to control the power output. And therefore, we offer the possibility to have a direct meter communication. The difference is that it's now times faster. Once a second, the power output is adjusted on the MyPV application. And in that way, MyPV is not only the power regulator, it's also the controller. The disadvantage, and this is one you have to think about, is that we are not part of the SMA Home Manager's energy management. We are not visualized inside the SMA Home Manager's front end. And there are advantages for both options. It's up to the customer to decide which way he prefers. We are completely flexible, and both ways are in use in many times and work really perfect. So you have both options when you control our device with SMA Home Manager, and you just have option 2 when you control our device with an SMA Energy Meter. All right, Now we have talked about the way to communicate with each other, and there are also the links included in the slides which you can use to go directly to the manual once you start your first setup with SMA and MyPV. And now there's the AC Alpha 2. As I already told you, it's an immersion heater which is assembled either in a hot water tank or in a storage tank. Both is possible, and it's an all-in-one solution, which means that the immersion heater, the heating rod, and the power stage, which does the linear power control, is combined in one product. And here we again see why a fast and linear power control of the immersion heater is so essential, because the PV power production is changing permanently. The weather conditions are changing, clouds are moving on the sky, and at the same time, loads in your building are switched on and off. And this balance, the difference between those two things, are detected in the feed-in point by an SMA device, either the home manager or the energy meter. And this is the essential metering point which MyPV needs to react accordingly. And the communication between those components is happening via a router, via the local area network. So for the AC Alpha 2, there is the option to communicate with the router either via a patch cable and an Ethernet cable or via Wi-Fi. Both is possible, and within the same network, also the MyPV, the SMA component, is available to provide the info from the feed-in point we need. The AC Alpha 2 is a successor of a product named AC Alpha E. It's still in production, and we plan to replace the AC Alpha E with the AC Alpha 2 until May this year. And that's why I'm just talking about the AC Alpha 2 right now, because when you order a device like this today at MyPV, you can be sure that you will receive the new one, the new AC Alpha 2. And there are several benefits with the new generation. While the AC Alpha E had a maximum power output of 3 kilowatts, AC Alpha 2's maximum power output is 3.5 kilowatts. You can see there's a color touch display on the device, which makes it very easy for you to do the setup, and it's a very intuitive way to handle the device. For the AC Alpha 2, it was just possible to access the device settings via a web setup. This web setup is also available for AC Alpha 2, but beside that, you can also do the settings on the display. For AC Alpha 2, there is also the option to have Wi-Fi, and when you get the device in the parcel, you have two components, and this is meant with this icon here. We have separated the two main parts. The heating rod is separated from the power stage. What is the benefit? So both components come in one box, and they are very easy to be combined with each other. But when they are separated, you have the benefit that the plumber has an easy way and an easy work to install the heating rod in the tank, and the electrician has an easy way when he just clicks on the power stage on the immersion heater afterwards. So this is a way to make the installation much easier. There are several technical specifics, and this is a slide where I meant at the beginning we are not going into every detail now. When you receive the PowerPoint presentation after the webinar, you can just read it and think about it when you have time. One thing that is very essential, I want to mention it, is our way of power control. We do not use thyristor controllers, we do not use phase angle control to adjust the power output. It's a pure sinusoidal power output, just as an inverter scales up and down its power. And that's why we are grid compliant with the terms of the grid operators. So you can rely on the product that we have made our homework as a manufacturer. So, power to heat increases your PV self-consumption ratio, and there's a diagram from the Technical University of Berlin. I'm using it for many years already, and here we see how many self-consumption ratio is possible, for example, in a single family home using a 5 kilowatt peak system. And we see that just 1/3 of the energy which is produced by the panels is used directly in the building. The rest is fed into the grid because PV power production and demand in the building are not happen at the same time. So one way to improve your sufficiency ratio, your self-consumption ratio, is to install a battery. Of course, you can do this, and you have an amazing improvement. You double your self-consumption ratio by a factor of 2. And if you use an ACLV2 as an alternative, you increase your self-consumption ratio even higher at much lower investment when you compare it with the battery. But as I said, we do not compete with batteries. You can use both technologies together, and this leads to a self-consumption ratio of more than 90% in this example. When there is a battery should be charged with priority. Once it is heat in the boiler, we cannot get back electricity out of it. But during the spring and summertime, we regularly see that the battery capacities are exhausted sometime in the late morning. And from this moment forward, we have plenty of excessive power to use for hot water heating, for example. And how good this works can be seen on this chart. This is an example with an ACLV-E, and it's controlled by SMA Home Manager. And especially here in the afternoon, we see how good this linear power control works. It's decreasing its power output in a way that not more power is used than currently is available by the PV system. And here we also see the good combination with the battery storage. After the battery is fully charged, ACLV2 or ACLV-E in that example increases this power output. So the battery has priority before our application, as it should be. And then there's the solution actor, which means the heating rod is separated from the power stage. What remains is just the power stage, and this makes you much more flexible for your application. For example, now you can use an immersion heater that is already on site at the customer's place. You do not have to disassemble this immersion heater in his tank, so the whole installation is purely electric and not hydraulic. You do not need a plumber anymore, and you can retrofit an existing immersion heater. There's a 3 kilowatt unit named Actor, and there's a 9 kilowatt 3-phase unit named Actor 9S. Here are the technical specifications for your information. After the webinar, you can check it if you like. One thing to mention on the technical specs for Actor 9S is that it always needs a neutral conductor on the load that is connected. It's used in a way with a star connection. It does not work with delta connection. And for all the customers who want to be sure that the components perfectly fit together, I have good news here. MyPV is also offering accessory parts, which are an immersion heater with 3 kilowatts, a single phase, and an immersion heater 9 kilowatts 3-phase for the Actor 9S. But practically, you can always use immersion heater from third parties as well, as long as the technical specifications fit together. The Actor comes with 7 operation modes, and these are all available out of the box. We do not charge a special fee or something when you want to use other modes. They are all available and all of them can be used. And before I hand over to Daniel again, I want to describe the most common way to use the Actor, which is mode 1. And in that way, it basically does the same thing as the ACLV2. The difference is you can use existing immersion heaters with this solution, and you have a much higher power output of 9 kilowatts possible. Here's the display. It's the same display and the same visualization we are going to use with ACLV2. So for all of you who are already familiar with an Actor, it will be very easy in the future to work with ACLV2 because the display is set up in the same way. And also an example for Actor, it's a 9S version with a 9 kilowatt immersion heater connected to it. And here it's an example without a battery system. And yeah, what you see here perfectly is the power adjustment on the immersion heater, which ensures that just excessive power is used. No power from the grid is used for heating, so excessive power only. Why is there no power output in between 11 a.m. and 12 a.m.? Probably the target temperature in the tank was reached during this time, and then there was hot water used around high noon, and in the afternoon we heated up the tank again. All right. Benefits, the installation of the Actor is very easy. It's a very intuitive way to do the settings on the display. Also, the manual that I have shown before describes how to do this on the display, but you always have the option to use a web setup as well when you're inside the local area network at the customer's place. And there's an online calculator which helps you to get an idea of the possibilities. Here you can adjust a PV system, hot water demand can be adjusted, the size of the storage tank, and it gives you an understanding of the possibilities using a MyPV product in your building. You can also choose if there is a battery or not, and it immediately gives you the results for self-utilization ratio, independence ratio, and it gives you an estimation of your annual operation costs, because you can also adjust a price for your conventional heating system. You can adjust the feed-in tariff and the electricity rate as well. It's a very great tool to get a feeling of the possibilities. I really recommend it to you also for your consultancy work or for your sales work. Use this tool to give your client an understanding of the advantages that are offered by power-to-heat applications. And finally, there are 2 slides left which deal with the off-grid application that I mentioned at the beginning. So far, we just talked about on-grid systems from SMA and MyPV, but there is also a way to use Actor and Actor 9S, not ACL2, but the Actors in off-grid systems. And in off-grid systems, there is per definition no feed-in point. So there is no SMA Home Manager and no SMA Energy Meter available, which provides the information of excessive power to our device. So how does it work? Here are examples of projects that are already working in that way. And they work in a way called frequency shifting. Frequency shifting is something that is done by an SMA Sunny Island. The reason why the Sunny Island is increasing the frequency in the local AC grid is to tell the PV inverter that the battery is reaching the state of full charge. So he has to decrease the power output because there is no way to use the energy in the off-grid system anymore. What happens is that the Actor and the Actor 9S are listening to the AC frequency, which is adjusted by the Sunny Island. And they use this frequency increase as an indicator for excessive power. And in that way, Actor is starting to heat up a water tank before the PV inverter is decreasing its power output. And in that way, you utilize energy from the PV system that otherwise would be completely unused. It would be completely wasted because there would not be a way to get rid of the energy. And we avoid the shutdown of the PV system as long as we can heat up the tank, for example. And the whole control is on SMA side by the Sunny Island, and the Actor is used as a power regulator. And this is possible until the hot water tank is on target temperature. Afterwards, the frequency is automatically increasing higher and the PV inverter shuts down. We can also adjust this frequency range on the Actor. So for 0 watt output and maximum output, there are 2 frequency settings possible, but it works off the shelf with SMA Sunny Island. We are The factory preset is that we have 0 power output at 50 Hertz and maximum power output at 51 Hertz. And in that way, it works perfectly with the Sunny Island. We have made this experience several times in Austrian mountain shelters, on avocado farms in Western Australia, and even in a Belgium research station on the South Pole, where this system is working in exactly that way. So these are not some stock pictures we have here. These are real projects where the actor is controlled by an SMA Sunny Island. All right, and now it's up to Daniel and to describe the SMA products which are relevant for MyPV. Daniel, I think you have to reconnect your mic and camera. Yeah, here you are.
Thank you, Graham. All right. Thank you for the great speech about your system. I will now go on with a couple of words about our SMA system, what we do, even though Reinhard already described the basics or the main goal and the main idea behind SMA. So what do we do at SMA? What do we want to provide the customers with our home energy management system? The main goal, or what do we want to provide to the customer, are advantages, basically, and the aim is to reduce energy costs and costs related to energy consumption over long and short term. Number one. Number two, increasing the customer's independence from the electricity grid, increasing self-consumption through a variety of other devices, such as gas heating solutions, as MyPV or e-mobility, you name it, wherever you can put your electricity or your own produced PV power into. And finally, provide the customer a perfect overview of all the clear overview of all the electricity flows, how much is being produced on my rooftop, how much are my devices consuming, is the consumption of my devices optimal, or can it be optimized some more? And if so, SMA is here to provide the possibility to optimize those electricity consumption patterns. So the goal in this would be to, like I said, increase self-consumption by shifting loads, which is something that Reinhard already described at the beginning. For instance, you have some device, it doesn't matter what it is, it can be the MyPV AC Elva 2 or other model, or it can be a dishwasher or something. Basically a device that you need to run at some point of day, and doesn't really matter what time it runs, but you want for the device to run ideally for free, meaning being 100% solar powered or solar dependent. For device such as MyPV Elva is ideal for that, because the energy manager can send the information, hey, listen, we now have PV surplus of 1 kilowatt, 2 kilowatts, depending on how large the customer system is, and we will have this surplus for a foreseeable period of time, 30 minutes, 2 hours. So you can use this electricity to heat up the water in the tank. Right. How do we do that? With the Sunny Home Manager 2.0. This is the Sunny Home Manager is basically the heart and brain of the SMA home energy management system. It is a DIN rail mounting device, which means the installation does require a professional. It's not as easy as a actor, but yeah, it's basically, it usually comes in when the PV and the inverter are installed at the same time. The Sunny Home Manager can communicate with up to 24 devices, and you can actively control and manage 12 devices at the same time. So you can communicate and you can set and control and manage the immersion heater, the MyPV. You can measure your wall box, your water bed, your pool pump, your I'm not sure if I said wall box. You can measure the consumption of a fridge or dishwasher, and really anything you can connect to the home manager. At the same time, the manager, energy manager, is the computing power that decides which device should be running at what time, how long, how much electricity should be taken from the grid, how much electricity goes into the battery. So really, this is the brain. And with the Sunny Home Manager, the customer also gets the access to free the Sunny Portal or the Energy app, which is the app or portal, desktop portal, in which the customer can see all the electricity flows and B, also control and manage and set run times and run times and electricity loads and so on and so forth. Here are some of our other devices, mainly inverters. For this use case with MyPV, the most relevant is like I said, the home manager and the energy meter, I'm sorry, and the Sunny Island. I'm not sure if you can see my cursor here, and the Sunny Island, which basically enables the customer to create a completely off-grid solution, just like Reinhard said in his last 2 slides. All right. Right. So here, basically, again, what Reinhard was saying before. Here we have a model house with PV generator or PV modules on the rooftop. The electricity that is generated there flows down into the inverter. The inverter communicates with the home manager. And the energy manager computes. Here at noon, there's enough sun for, let's say, the AC Elva. This is the Elva E, the previous version or previous generation. So here's enough electricity to run the heating rod for a certain period of time, and at the same time there is still enough electricity to run, let's say, the dishwasher. The heating rod, the MyPV heating rod, communicates. They're in the same network, so they communicate via internet. And same thing, you can have a internet-ready washing machine or a Bosch washing machine that communicates via EE-bus. So these things can technically speak with the energy manager, with the home Sunny Home Manager, sorry, and the home manager decides how long and with how much power these devices then will run. Right. So here, like I said before, the main goal of the Sunny Home Manager is to use as much own PV produced electricity as possible, especially to use it for thermal loads for the heater, because not everyone has a battery. One step back, it is fairly important to use the electricity wisely and to store it somewhere. And basically, the customer has two options: A, store it in a battery, or B, store it as a thermal power. When you think about it, battery is not a cheap option, or not the cheapest option, and a water tank or a buffer tank is basically in every single household. So if you are looking for a economic solution how to store your surplus PV electricity, and you already have a water tank, you can simply add the heating rod and store your own PV electricity as a thermal power in your water tank, which is basically maximizing the utilization of your PV system on your roof with the energy manager, with the home manager. The MyPV Elva 2, this one is, it can communicate, like I said, it can communicate via internet, and it can be integrated either via, I'm not actually really sure about that, Wi-Fi plugs or relays, but maybe that would be a question for Reinhard at the end. And it can also communicate directly via a SMA-owned SEMP protocol, which stands for Simply Energy Management Protocol. Right. And here really just another look at how the system really works, how it's interconnected, be it with the AC Elva E or AC Elva 2 or the Ector. Again, here you can see this is basically a schematic where you have a PV modules which create electricity that communicates with the inverter. Here down the line, there's a inverter, a battery inverter, or inverter and/or battery inverter, some Wi-Fi sockets, other appliances, and it all communicates with the Sunny Home Manager via a local area network. That right. Next one. Okay, here this is actually unfortunately really small. The second picture, that's one now in the front. This is basically how it looks like when you try to add a new device into the system. So it's actually fairly simple. Once you have the Sunny Home Manager running, and once you have the MyPV Elva in one network, you can simply here click on Add Device, and it will find the device, find the Elva, and then you can click on Add, and those two devices start communicating, and you can see automatically the device appearing in your Energy app or in your portal, and set the runtimes. And I think this will be the last slide of mine. Yes, correct. So how it all actually works, or not how it all works, but what can the customer do and set. So the customer can decide how much electricity from the grid he wants to use, and basically the customer can decide, does he want to behave more with focus on his economics, or with more focus on the ecology of his whole system. So basically he can decide how much power from the grid he wants to take, and how much power from the sun he wants to utilize. So here this is in the portal. This is like a sliding switch or sliding button that the customer can click on and slide from side to side. And if it slides more to the pylon icon, it will use more grid electricity, which will then be adjusted here. So in this setting currently, it says it's using only 20% external supply and 80% PV power generated from your own grid. And this gives the customer again more freedom to basically decide how much electricity from the grid he wants to utilize, or he or she wants to utilize. At the same time, the customer can decide how big of a priority the device is supposed to have. So let's say the heating rod is very, very important because if it doesn't work, I don't have hot water at the evening so that I can make a shower with. So I can set here, I want my heating rod to run with 80% own PV generated power, and at the same time, it has the highest priority of all the devices. So the home manager makes sure that that at the end of the day, the PV at the end of the day, my PV ELVA heating rod ran at least an hour or 2 hours or whatever time it takes for the heating rod to heat up the water tank. And with a high priority, the Sunny Home Manager makes sure that it did run the specific amount of time for it to heat up the water and basically achieve the goal, even if there was not enough PV power. In the case if there wouldn't be enough PV power, it would take power from the grid, but it would definitely be heated up by the end of the day. So yeah, this is actually everything that is managed by the Sunny Home Manager. Like I said, that is the brain of the SMA system. And like Reinhard before said, it sends long story short, sends all the information to the ELVA, and basically powers the system. And here I see Reinhard, and that's last slide to the SMA system. I see Reinhard is back in the picture as well, so I'm taking the word. I'm giving the word back to Reinhard.
Thank you, Daniel. Let's remain on your slide for a moment.
All right.
These steps that Daniel described so accurate, they are also explained in our manual. So there are the recommended settings for the SMA Home Manager shown in our manual. You also see where we recommend to set the priorities. Usually we set the priority low on our devices, or the installer who does the commissioning sets the priority low, because in our philosophy, power to heat is always the last application to use. When the devices come from the MyPV factory, they are configured in a way that just excessive power is used for hot water heating. What is always an option, I did not mention it at all so far, is that we can maintain a minimum temperature in the tank if the customer wants it to be maintained. So we ensure a minimum comfort. Therefore, we also take power from the grid or from the battery when there is a battery. But when you get the device from our factory, it's just using excessive power. Okay, another thing that came to my mind when Daniel was speaking, we have sometimes been asked if we require the radio sockets from SMA. No, we do not. Our devices are directly connected to the AC building installation. So there is no switch, no radio socket in between. If SMA does not tell us to heat, we are not heating. So there's no requirement for an additional switch in between. All right. Our products, your benefits. I just have a few slides left to sum up what we talked about today. We think that hot water heating is the easiest way to increase the self-consumption ratio in your building. The storage we require is usually available. It is already there in a residential building, and with our technology, it's very easy to make use of this additional storage capacity at low investment. So the future we are going to face, hopefully, is a future where we see PV systems on all our houses. And when we want to utilize as much energy from our own power plants above our heads as possible, we need all storage capacities we have. One part of the solution is a battery storage. That's quite clear in our perspective. It's also about using hot water storage or space heating tanks as well. Okay, linear power control. This is the essential part when we are talking about hot water heating with PV power. Please forget all immersion heaters that are just switched on and off. It has nothing to do with smartness, with an intelligent way to create hot water with PV power, because you cannot adjust the power on the hot water heater. It's just on and off, and it's using power from the grid, or it's not avoiding feeding into the grid. So you always need a smart component in between which adjusts the power output accordingly in a way that there's always a balance in the feeding point. And that's MyPV is good for. That's our key know-how. We are producing power stages for resistive heaters. All right. Where to buy? We have a very well-developed distribution network, especially in the German-speaking countries, and it's on the increase in other countries as well. There are already many countries where we have a sales partner, and if you want to have a direct information regarding sales, please forward your question to Talal. Talal, you're still with us. Just enter your email address in the chat. And once I send out the slides of today, you will see it as well. All right, information about we present about the things we talked about today are on the website available. No questions. In our info center, you find all the data sheets, all the manuals, SMA manuals, for example, very important, and also wiring diagrams. So you can download this information at any time. You do not even have to register with an email address or something. You can get this information you need every time right now without any hurdles. Okay, the webinar has been recorded. If you know someone who's interested in the technology as well, please recommend our YouTube channel to him. I think it will be at the beginning of next week when the record of this event today will be online, and beside that you will find many webinars we already have done and also many videos with short tips. For example, an actor commissioning video here where we had the camera in front of the display and just made a commissioning of the actor and show how easy it is to do the setup of an actor. All right. Thank you very much, ladies and gentlemen, for your time. Daniel, please be so good and switch on your mic and camera again. If you just want to say some final words to our audience, it's now the time for you.
Back here. Yeah, it was a great pleasure doing this with you, Reinhard. Also, thank you everyone for joining. I hope it brought some clarification or more light or got you excited or interested in our systems. And yeah, I'm looking forward to another webinar with everyone here.
Yeah, thank you as well, Daniel. It was really a pleasure to do this with you together. And ladies and gentlemen, the combination of SMA with MyPV is a very well proven combination. It's out there for many years already, and we have several hundreds of systems that are working in the way we have told you about today. Yeah, that's all for now from my side. I want to say thank you for your time. Yeah, it was great that you have spent this hour with us, and wherever you are, please take care of yourself, and all the best from my side here. All the best from Upper Austria. Thank you very much.
Also, thank you very much for your time from Germany. Maybe one last thing. If you have any questions, feel free to ask now. We're in no hurry to run away. So if there's any questions, feel free to text or post in the chat, or yeah,
or via email afterwards.
Afterwards.
I send out the presentation in a few minutes, and if you have a question later on, just answer to that email, and we are going to answer the question and give you the information you need. All right. Thank you very much, ladies.
Empowering the solar future.